So actually, I wanted to give this presentation for walls. I wanted to start with inspection, but anyway, it's better to have basic concepts before we go into details of inspection. That's why I started with the basic concepts. So we'll have a short presentation this week about the basic concepts of walls, and then next in the next session, I think we can go for inspection details, inspection and testing details. So let us in this presentation we will be covering about. I mean, we'll give an introduction of walls and application of walls, type of walls, parts of walls, and principles of operation. How each type of wall operating. That principles of operation that we'll discuss, and then material of construction. With this, we'll conclude this part one. So that in the next session we'll have about inspection, and we'll go in detail about valve inspection and testing. Okay, we'll start with this part one about basic concepts. So valves, as you know that we are very familiar with the valves actually. This it's not only the industrial valves, even our running water tap is also a type of valve, and we have so many type of valves in our day-to-day life, and we are seeing that. And even this valves are actually the valves were they started, even Romans started using valves in about 2000 years ago. They were the first one to manufacture a valve made up of steel, and 2000 years ago they made a valve which is just open and close valve, that's all. Similarly, and over the period, this valves have even some 200, 300 years ago, valves means there should not be any leak. That was the principle of that was the requirement of a valve. A valve should not leak. But along the over the period, it has come to conclusion that it's not that all the application doesn't require watertight valves. There are certain application where you can allow certain amount of leak, which is not going to harm any, which is not going to detrimental to the operation or wherever that valve is used. So based on that, so different type of valves and different for different applications were invented, and now we have got so many types of valves currently being manufactured, and it's being applied to varied industries like chemical industry, petroleum industry, and other industries, irrigations, and even in our domestic appliances like washing machine and other things. So we are coming across so many type of valves. So this is the basic. The actually valves. What is valve? Valves are devices that work to control, regulate, direct flow within a system or process. This either it will control, regulate. Control means on and off. Regulate means it will regulate the flow, and sometimes it will direct the flow. It will direct the flow from one direction to another direction. That is also a type of function of a valve. So this angle valve functions like that. So this is the basic definition for a valve, and there are so applications. So valve applications, there are three type of applications. One is isolation valves, that is on-off valves, where the flow is completely stopped, and completely stopped and completely and fully full on or full off. So this is isolation valves or on-off valves. That what we call that. It is called as isolation valves or on-off valves. this type of valves will, where the flow will be completely stopped or completely full 100% flow will be there. And second type is regulation valves or control valves. There you'll be able to control the flow to the requirement, because see, so certain boilers or boilers may require a fluid to flow to a certain level, so that burning process is not will not stop, so that they require that flow to be controlled. Say 50% of the fluid should be in flow always. It should not, if the burning requirement is required more, they will increase the flow or they will decrease the flow, so that the flow is needs to be controlled there. So that in that type of situation we need control valves. So another type of another type of application is this control valves, where the flow is controlled from 0 to 100%. Either they will stop it completely, or they will release it. They will open it 10% or 20% or 50% or 75% or 100%. It can be done with the control valves. That is on another type of valves. And third type of valves is safety valves. Sorry, safety valves. Safety valves is protection against overpressure or flow reversal. That is safety valves, safety relief valves, pressure relief valves, check valves. These are all safety valves. So even our pressure cooker is having a safety valve. You know that there is one vessel type thing is there in that the pressure cooker, where we have where the cooker is being used for cooking a rice or something like that. So the pressure, the weight on top of that pressure cooker is calibrated depending upon the maximum pressure that vessel can tolerate. So it's calibrated accordingly. When it reaches that level, that weight will go up and release the excess pressure. That is also a type of one. That is safety valve. And pressure relief valve and safety, there are two types of valves: safety relief valve and pressure relief valve. These two are different. Most people will think both are same, but these two are different, because safety relief valve will open only it will open pop up this open pop up open, they say. When certain pressure reaches, it will open suddenly. Pressure relief valve will be open in a for a continuous flow. That is the pressure relief valve. The flow will be continuous and to a certain pressure. It will be open to the flow to a certain pressure continuously, and if it exceeds, it will close. That is the function of a pressure relief valve. Check valves are a type of safety valve where the flow reversal is prevented. So it's a unidirectional. It allows only unidirectional flow. Only one way the flow can happen, and the reverse flow is prevented. That is another type of application of this safety valve or protection valves. And so next is type of operation. Valves are operated in some valves are operated using a handle, lever, and hand wheel, and some gear. That is these three are manually operated valves. Automatic operation valves are what you call control valve. It's operated electric actuator, pneumatic actuator, hydraulic actuator. Electric actuator not always control valve. It can be on-off valve also. But only thing, the on-off function is done by a electric actuator. It will when this switch on, the motor actuator motor switches on, and it will open or close the valve. And pneumatic actuator function based on the pneumatic supply. Hydraulic, as you know that based on oil pressure, the actuator functions. So another type of operation is that automatic response of this thing, like check wall, pressure relief wall. These are all doesn't require any external operation. It operates automatically based on the pressure. Pressure it is allowed to flow through. So a check wall, when it is designed, if it check wall will design, check wall will allow certain pressure to flow up, unidirectionally, and return flow is prevented. And safety wall, they will set a pressure, say 10 bar. 10 bar. If it exceeds 10 bar or exceeds 10 bar, it will up to they will set up a maximum the pressure they will set up as 15 bar. If it reaches 15 bar, it will open and release the pressure like that. So it will not, no external operation is required. These are all automatic valves. So there are three type of valve operation: manual operation, automatic operation, and auto response valves. These are all three type of operation of valves. As I said, this is hand wheel operation and lever operation and electric actuator, pneumatic pneumatic actuator, pneumatic control valve. This is hydraulic control valve. This is electro pneumatic control valve, electro-pneumatic control valve with the positioner and all. And principles of operation. There are three main principles of operation. One is linear motion valves, second is rotary motion, and third is self-actuated valves. Linear motion valves, where the closure element moves over a threaded stream up and down. The closure element, that closure, what either it shall be disc or any other ball or any, no, it's not a ball, it's a disc or any other closing element, it will move up and down. Up and down. That is linear motion. So these valves will have linear motion. That stem is connected to that closing element, and this closing element, when the hand wheel or when the stem is rotated either by hand wheel or motor or any other actuator, it will act upon that disc, and the disc will either go up or go down based on the rotating direction. So this is linear motion valves. So mainly gate valves, globe valves, pinch valves, needle valves, diaphragm valves will have this type of setup. This is linear motion valves. Rotary motion valves, we know that closure element connected to the stem, when rotated, it will turn 45 degree or 60 degree, 90 degree, and it will and if it turns, it will open the valve, or and again the return. If it is returned, and it will close the valve. So the direction is rotary motion. Self-actuated valve, as you know, that the safety relief valve and pressure relief valve, it doesn't require any motion. It opens automatically, self-actuated. So when the check valves, when the closure element will automatically open when the flow is there in check valve. When the flow is not there, it will automatically close, thus by preventing the reverse flow. So these are the three type of principles of operation. And we'll go. This next is valve pots. Major valve, the valve pots consist of two types: pressure containing parts and non-pressure containing parts. Pressure containing parts mainly consist of body, bonnet, cover, retainer, etc. The main body, bonnet, and cover, retainer, etc. This bonnet, cover, and all is different for different valves. It is mentioned as say for globe valve and gate valve, it will mention as bonnet. For ball valve, other thing, and they will mention as cover and other type of valves, retainer or something like that. So This body bonnet cover, retainer, and everything is mainly uh, casting or forging material mostly, and some gate walls are manufactured by fabrication also, but still majority of body bonnet and other this thing are made up of casting and forging, and these are pressure containing parts, because the main pressure is being contained inside this enclosure. And other non-pressure containing parts are seat, stem, disc, and wheel, and fastener, and the etc. These are all called non-pressure containing parts. The seat, stem, and disc is also called as this internal parts also called as trims. And these are all wall parts. Then wall, okay, this is wall parts. Okay. So basically, wall consists of a body. This is the body. So up to this is okay. One second. So body, and on the top side of body is a bonnet, and the stem is goes through this bonnet and enters the body, and you will have a disc or ball or anything according to the wall type connected to the stem, and the stem is also on the other end connected to mechanism, rotating mechanism, either by lever or hand wheel, or I mean actuator, anything based on the type of wall. So these are the main body parts: body, bonnet, and the packing area is called the where you have all the gland packing, back seat, and other packing material. Everything is assembled here in that gland area. So back seat is mainly for globe wall and gate wall. Other walls will not have back seat. Back seat. You know what is the? Anybody knows what is the use of a back seat? Back seat. Why they have back seat in the walls? Because most of you have done a wall inspection, right? Yarga தெரியுமா? Yarga. Anybody knows?
Packing, sir, that pressure containing bonds up to packing area, gland area, sir. During the back test, that pressure is withstand or the packing packed no, sir. During the assembly, that packed is withstand the pressure or not. That
Okay.
purpose only we chose.
No, no, that is there. Why they have back seat in this? Because instead of that also they have packing. See, all other why they should
Pressure containing parts up to packing boundary, that boundary area, pressure containing boundary part is up to that area only. Stem, the linear motion stem along with the bonnet area. So that is a boundary area. That
no,
must
actually,
be
the main
corrected.
purpose of a back seat is you can change the gland packing even in the even during the operation of the one. If the back seat is there, if the back seat is there, you
Yes.
can change the gland packing even in the valve in operation. You can open that and you can change the gland packing, but there will not be any leak. That because that gland the back seat will prevent any leak. So back seat will be the first one to come up to prevent the internal pressure.
It acts
Before,
as a seal, sir. Seal
uh,
between stem and bonnet.
yeah, this seal will prevent any. So because of that seal, you can change the gland packing even during the operation. So that's why we are checking the back seat during the testing, wherever this back seat is provided. For not all the walls will have back seats. Okay. and pressure controlling valves. Okay, backside is valve parts. Next is next we'll go to common valve types because there are a lot, so many valves are there. But we'll mainly will what we are dealing with is globe valve, gate valve, plug valve, ball valve, butterfly valve, check valve, pressure relief valve, and safety relief valves. These are all the major valves what we are as inspectors we are will be mostly dealing with. So first we'll go to globe valve. Globe valve we have three type of globe valve. Three type of globe valve. One is this is angle valve, and this is what do you call angle valve. No? This is T type valve, this is Y type valve, and this is angle valve, right? Yeah. Three type of valves you can see in globe valve. But basic function will be same, but only thing it will have the design is different. The flow direction will be different. So global regulation contains that's actually what happens is the functioning working principle of this global is only thing. It contains a flat plug or this thing. This is the plug and ring shape. The seat is there's a seat here. So when the flat plug is completely fit into the seat, the flow is prevented. Flow is restricted. You can control the flow of fluid by adjusting the position of this plug. So if it raises, it will open. It will open this area, and the flow takes place. And if it closes, come into contact with the seat, it will close this opening, and the flow is stopped, completely stopped. By adjusting this position, the flow is also controlled. So it is used in a control valve also, as a control valve also. So this is the operating principle of globe valve. So here you can see the flow, the inside flow, and you will have the plug here. This is the seat area, and if it closes, the flow is completely stopped. If it opens, so when the if it opens, the flow occurs. Flow occurs, and you have in the data sheet how do you call this flow? What type of valve is this? Anybody come across data sheets? This flow. See, suppose you are facing this wall like this, and in the data sheet, how it is mentioned? Anybody knows? The flow characteristics. No. Flow characteristics is mentioned in the data sheet.
Yes, sir. Some percentage wise mentioned, sir.
No, it's not mentioned. Flow,
So what was the flow, sir? What was sir?
flow down. This is flow down.
You down outside or up, sir?
Up, yeah. This flow down.
The, down to up.
Down to up. They will
Yes, I
mention this flow down or something, flow up or something like that. Flow over, flow below or something.
Yes, yes, okay, sir.
Yeah. This is flow down.
No, down. Yes,
Because
down
this
to up.
valves can be used as in both directions. Sometimes they will use it with this side, flow over. Sometimes they will use it as flow down also.
Yes, yes, sir.
Yeah, based on the requirement.
As per data.
I'll show you this. This is here. See, here is flow down. This is the flow down, and you can see that going up, and the flow takes place. Here it said actually in this thing they have mentioned wrongly here. What they are saying, media pressure assist positive sealing. Actually, it's not only if the flow over direction if it is done. If the valve is changed to, In the other direction, the flow will come and valve open and goes through this way. And if it closes, the flow pressure will be act upon this plug, and it will give a tightness. It will give the tightness. But here it is not assisting. Actually, it is what is mentioned here is wrong. You understand? Anybody is having any doubt here? This flow over, flow down.
Okay, sir.
Yeah. If the same wall, if it is installed in the opposite direction, the flow over condition will assist the plug to to have a close contact with the seat. But here it is actually resisting the sealing. Because the pressure is here, in this direction. Okay. So this is a globe wall, and globe wall applications of globe wall. Globe walls are used in many applications wherein steady fluid glide is not necessarily required, such as in a chemical feed system and turbine tube oil. A loop oil system and all they will use because where the steady flow is not required, there mainly the globe wall is used. And prime usage in power plants and wastewater plant. In the lubrication system, because in the lubrication system they don't require steady flow, so that's why they use globe wall. These are the applications of globe wall. Okay. Next is gate wall. Again, this is also linear motion. Like globe wall, the motion is linear. Like this globe wall. So the linear motion is this is the linear motion. So when we open the wall using this handle, this threaded stem will go up and down. So this is what we call linear motion. Similarly, the gate wall also have a linear motion. The gate, which is here, will go up and down, making the wall open and close. So this is the gate wall. Only thing we have, instead of that plug, we have wedge-like construction here. Wedge-like construction here, seated between these two seats, and all other. We can see all other parts are almost same here, because there is a body and bonnet and gland packing, stem and handle. Everything is almost same. Only thing, the inner area, you have that instead of the construction of globe wall is different than gate wall. Here you can see the flow will be uniform. There won't be any loss of pressure because of this construction. You can see lot of there will not be any loss of pressure. That's why when there is no loss of pressure, when loss of pressure is not acceptable, then they will go for gate wall. They don't go for globe wall. See, globe wall will constrain the pressure, because the flow comes here, goes through this upward and goes again, because there's all this what you call configurations, construction. This thing will automatically reduce the flow pressure. So that's why they don't go for this globe wall when there is a steady flow of pressure is required. So in that cases they'll go for gate walls. So gate wall, as I said, work by inserting rectangular gate of wedge into the path of a flowing fluid. They are operated by threaded stem, again like a globe wall, which connects the actuator or hand wheel or anything like that to the stem of the gate. If the valve has a rising stem, its position can be seen just by looking at the position of the stem, because you can easily see if it is the stem is rising up, you know that the valve is open. If it is closed, if it is it is near the handle, if the stem is almost near the handle, you know that it is almost closed. So this is the stem. When the stem goes up, fluid goes through without any hitch, and it will again when it is closed, the flow is stopped. That's all. This is a very simple this thing. So this is the functioning of the gate wall. Gate wall, how the gate wall is functioning. Here he is saying that the media pressure is acting assist positive sealing. That I can accept, because see here when it closes, you can see this media pressure is acting, so that this side of seat is closed by this pressure. Because this wedge will come close in contact with the seat, will have a tight contact because of this pressure, so that there won't be any leak. Okay, this is a gate wall, and types of gate wall applications are oil and gas industry, fire hydrants, and other this thing. Because based on applications, they're able to handle high flow rates, because you can see that the flow is not at all obstructed because of the construction, the type of construction. The flow is not at all obstructed. That's why they go for wherever they need such type of requirement, they go for gate wall. And next is ball wall. Actually, ball wall, this is instead of linear motion, it has got rotary motion. Instead of any stem going up and down or anything, the blocking device, which is a ball, which with a hollow spherical this thing is connected to a this thing stem, small short stem, and when it is rotated, it will have this opening through the bore, and if it is rotated another 45 degrees or so, that it will block the flow. That's all. It's a very simple this thing. This is a ball wall. Here you can see a ball wall is shut-off wall that controls the flow of a liquid or gas by means of rotary ball having a bore. By rotating the ball a quarter 90 degrees around its axis, the medium can flow through or is blocked. Here you can see the ball. This is the ball, and you can see the hollow portion is towards the bore. So it is fully open here, and now it is getting closed. Now it is fully closed. This area comes to this, takes a turn towards the bore, and it obstructs the flow. This is a simple mechanism. And this is another type of wall. This is we call ball wall. And this is how it operates. This is easy to understand that. So this flow is provided here. Now you can see the flow there. This is the operation like. And ball wall applications are used, shutdown walls, onshore, offshore, another primary petrochemical, major petrochemical industries is being used. It's also most of the taps, running taps, we are using here in our residences. It has got a ball wall mechanism. Because there is a quick, it can easily open very quickly and close also very quick. With the quarter turn, you can close, and with the quarter turn, you can open the valve. Next is plug wall. Plug wall is similar to ball wall. It's also a rotary type wall. Instead of ball, we have a plug here, which is having a opening. Similar to a ball wall. All rest of the construction is almost similar. Instead of a ball, we have a wedge like, plug like arrangement here. And similar to the ball, when the wedge opening is aligned to that bore, the flow passes through it, passes through the bore. If it is turned 90-degree turn, it will block the flow. That's all. It's a plug wall. This is called plug wall. You can see this plug wall. See, if it is turned, the bore is turned with aligned to the bore, the flow takes place. This is also very quick. You can open it quick operation. The quarter turn you can close, or within a quarter turn you can open the wall. So this is plug wall. Plug wall operations are where this mainly they are using in corrosive, flammable, toxic, and makes them idle for petroleum and chemical industry. This is a very simple wall. Butterfly wall is a very simple construction. And you can see it's not a heavy like other globe wall or gate wall. With the simple construction, it has got only one disc acting at the center, which opens and closes depending on the wheel rotation, hand wheel rotation, or actuator functioning. This opens and closes. It opens. It makes disc open or close, and very simple operation. And it's got only a disc here, and a seat also is there. This is a body and the stem. Very simple construction. This is the way this butterfly wall functions. There are in the butterfly walls you have a double offset and triple offset butterfly walls. Anybody knows about that? Butterfly walls, there are zero offset wall. This is a zero offset wall. There is no offset in that. And there are double offset and triple offset walls also there. Anybody knows about that? What is double offset wall? Butterfly wall. Anybody knows?
No, sir, you explain, sir. I don't know.
Double offset walls are in the disc. It's not this. You can see zero offset wall. The disc will be in center the center to this wall, and also to the flow. This is the flow direction. This is the wall. So the disc position will be center line. It will be in the center line, and this direction also it will be in the center. The disc also in the flow direction also you can see that the disc will be installed in the center line. Double offset wall, you will have the disc offset either this side or that side. Again, this offset to the wall. Offset to the wall means this is if this is the wall, this is the center line, right?
Yes, sir.
And you will see this double offset butterfly wall. This disc is offset.
Offset the disc, sir.
Offset, yeah, disc offset.
Disc is offset.
Disc the disc will not be in the exactly at the center of the wall. It will be
Okay,
any one side. There are two flanges, no?
Yes, sir.
This will be in any. It will be adjusted to any one, offset to one side of the flange.
Okay, sir.
And that is one offset. Another offset, the flow direction also. In the flow direction also, it won't be at the center. It will be offset again.
How to close, sir? Two disc is close, sir. In
Yeah, it will close. It will close.
okay, okay. I know instructions,
Yeah,
sir.
it will close. It will close. That is double offset. Triple offset, even this, apart from this two offset, seat is also offsetted. Seat is also offsetted. That is triple offset. But mostly they will use they'll go for a double offset butterfly walls. It's very efficient one, double offset than zero offset one.
What purpose, double seat, double, sir?
Because maybe flow or something like that. I don't know. I don't remember now. They use it mainly that advantage is more in butterfly one. I think flow and everything, efficiency, everything is more in the double offset one.
Okay, okay.
Wide variety of applications of butterfly oil. They are used in wide variety of process media industries, especially in water supply collection, distribution, pumping station, broad range use case, flow isolation. Depending on applications, they go for butterfly oil because this cost wise is cheaper than other valves. This is check wall. Everybody knows about this check wall. This has got the blocking device is connected on a hinge. Connected on a hinge. When the flow comes, this blocking device opens up automatically.
Yes, sir. Oh, yes, okay.
Automatically, the flow takes place. When the flow stops, it will automatically,
Close
due
the
to
disc.
gravity, it will close down. And reverse flow is also prevented. That's a simple mechanism. The purpose of check wall is to prevent backflow within a piping system. Check walls, even see in normal, we have a footwall. We call footwall in our wells, uh, irrigational wells and all. We have a footwall. That is also a type of check wall. So when the motor starts, the check valve opens and the flow from a well to the motor takes place. When the motor is switched off, this closes by preventing that whatever water remains in the pipe will remain there. It will not go into the well back, so that it will have a suction power. It won't create any vacuum, so that the suction power is retained. That's why we have a footwall in the, for irrigation purpose wells, open well where we use motors, no, water pumps. There in that pipe which connects from a motor to the well will have at the bottom of the pipe inside the well will have a check wall that we usually call as footwall. That is also a type of check wall. So main purpose of check wall is to prevent the backflow. That's all. This is in industry it is used in similar construction. So when the flow takes place, this wedge opens and allows the flow. And once the flow stops, it closes. And any backflow is reverse flow is prevented. Check wall find applications in nearly all the industries where fluids must flow in one direction.
Yes,
So
sir.
no reverse flow is acceptable. Where no reverse flow is acceptable, check wall is
Okay.
final. Yeah, things. This safety relief walls. This PRV, safety release wall, PRV. So the pressure, because of pressure, it opens, and this thing. A constant pressure, it will have a constant pressure, and constant flow also will be there. Pressure relief valves. And this is a pressure relief valves, and this is safety relief valve. Safety relief valves, you can see if the pressure goes to 10, so whether it is PSI or bar or whatever it is, the pressure goes to 10. If it is in the 6, it remains closed. The valve will remain closed. If it exceeds that 6 bar pressure or 6 PSI, whatever pressure, and reaches 10, it
Can we
automatically
reach the valve open, sir?
automatically open and
Automatically
release
open,
the
yes, sir.
safety. Yeah, it's used in boilers and pressure vessels mainly because any boiler or pressure vessel will not withstand a certain more than a certain pressure. So that in case of any malfunction of the system, any pressure builds up, this safety valve will be there to act upon and release the excess pressure and avoid any accidents. So safety valve operation is only to, in case of over pressure, it opens up and release the pressure. So this is the common valves valves we are coming across during our inspection visits. Globe valve, gate valve, plug valve. These are all, as I said, linear motion valves. Ball valve, butterfly valve, and these are all rotary motion valves. Check valve and safety relief valves will not have any this thing. It will operates automatically and doesn't require any external this thing. Again, this on-off, there are type of valves which have on-off valves where only the valves will open fully and close, and the full flow will take place, and closes, and 100% of flow is cut down. And another valve type of valve is regulation valve or control valves, which allows the valve to regulate the flow, 10% of flow or 20% of flow, even 100% of the flow also. So it will that is the regulation valves or control valves. Safety relief valves will act only on in the case of any excess pressure or where a flow a continuous flow is required on at a certain pressure, where pressure relief valve is used. So these are all the three type of valves, and we have seen the basic functioning and working principles of these valves. And now we'll see why we need a different type of valves. Valves are used for a variety of purposes, including isolating, controlling flow, preventing reverse flow, safety, etc. So different type of valves is required because of this different requirement. Starting and stopping flow or controlling the flow, or because to avoid any excess flow, all these are requirements. That's why we need different type of valves. When choosing a valve, you can consider factors such as media type, application condition, valve function, actuation method, maintenance requirements. All these are considerations before you choose a certain type of valve. Media type, application, what type of application is going to be used, valve function, what type of function is required, whether you need whether you need to prevent a backflow or whether you need to control the flow, and something like that. And actuation method, whether on-off method activation is okay, or you need a controlled activation, that is also should be taken into consideration. And maintenance requirement also. In case of if you need valve should not give you frequent maintenance also is not advisable. So that also should be taken into account. So that's why we have different type of valves to choose from. Then comes valves, material of construction. Material of construction, valve body materials are chosen primarily for two reasons: strength and corrosion resistance. These are two main reasons based on which the body material of valves are chosen. Strength of valves in terms of pressure and temperature of fluid is main and first consideration while selecting valve material. pressure and temperature of the fluid in which the wall is going to be used is a main criteria to choose the material. If it is a corrosive environment, you cannot go for a carbon steel, ordinary carbon steel material. Similarly, similarly, when there is a non-corrosive material, you cannot go for a duplex material also because it is very expensive. So you need to and high pressure and low temperature areas like European countries or in case certain fluid which is having low temperature. So based on so in that cases you need to have a low temperature material to be used. So these are the factors based on the pressure, temperature of a fluid are the factors. So to consider the material selection. And corrosion is another this thing for in corrosive conditions. You need to carefully select the material which is having a strong corrosion resistance. That is another criteria for choosing the material. So generally, what we have is steel. Steel actually. Steel that is steel. We have carbon steel and low temperature steel and high temperature steel, alloy steel, and super alloy steel, and non-ferrous material, and non-ferrous material, and other PVC or some type of other materials. What do you call? Actually, steel. People used to tell iron. What is steel is mainly the combination of iron and carbon. Without carbon, iron is not a strong material. Without carbon, people will say iron man, iron lady, and all. But iron is a very soft material. Iron is a very soft material. With the mixture of carbon, it becomes stronger. Without carbon, iron is a very soft material and cannot be used for it. It is almost useless. So the percentage of mixing of carbon is giving us the various type of steels. See, depending on carbon percentage, we classify the carbon steel as a low carbon steel. A low carbon steel, what do you call low carbon steel, is up to 0.3%. 0.3% is we call it as low carbon steel, and up to 0.6% we call it as medium carbon steel. Up to 1.5% we call it as high carbon steel. So more than 2% is cast iron. Okay, more than 2% is cast iron, and if some alloy is added, and we call it as alloy steel. We call it as alloy steel. These are the now we have low carbon steel, medium carbon steel, and high carbon steel. Alloy steel is the steel mixing with the alloy material like manganese, chromium, moly, and other alloy material. The mix based on the mixing percentage, we have different materials. Low alloy steel. Low alloy steel. What is low alloy steel? Is anything the total alloy percentage if it is less than 8%, that is called as low alloy steel. If it is more than 8%, it has got high alloy steel. And low alloy steel mainly used for low temperature. Low alloy steel is mainly called as LTCs, that is low temperature carbon steel, and high alloy steel is also called as high temperature carbon steel. It's only based on this two differentiation is only the alloy percentage. If it is 8% less than 80% total alloy, alloying material, then it is low alloy, and if it is more than 8%, it is high alloy steel. That's all. And after that, high alloy steel, we have another category called stainless steel. Stainless steel, that we have a different type of stainless steel, martinistic and ferritic, austenitic, and after that, duplex stainless steel. And another type of alloy material is super alloy steel, that what you call nickel-based material, copper-based material. Nickel-based material, you know that in Cornell, Hastelloy and other these type of material are called nickel-based material. Copper-based material is aluminum bronze and nickel aluminum bronze. These type of materials are copper-based material, copper-based alloy. Sorry. And as I said, this major part of the valves are body and bonnet, and these are all these two are made up of either by casting or forging. Majority of valves, it's either they manufacture it by casting method or forging method. Casting is a manufacturing process in which liquid material is poured into a mold which contains a hollow cavity of a desired shape of a body or bonnet, and then allowed to solidify. This solidified part is also known as casting. And it is ejected, and it is once it is solidified, it is taken out, and shaped up in the sense fettled, and we'll have a casting to the required as per our requirement, as per the mold, or as per our requirement, we'll have a casting of a body or a bonnet. And next is forging. Forging is another manufacturing process in which by applying pressure, hammering force or compressive force to steel billets, which are solid state, for getting desired final shape of material is achieved without melting. This forging is achieved without any melting, and it's only hammering and compressing the material, compressing the billets. So it is achieved without any melting process, and this is a stronger material than casting. Now, what we have a difference between casting and forging. So strength of casting. Here I have given this differences between casting and forging. As you know that casting is very large and complex parts, high production. You can mold. You can make a mold at any shape, and you can bring out a casting at any shape. High production rate. Once the mold is ready and the method is acceptable, and you'll have many number of castings poured, so that without any so the production rate will be more. Design flexibility. That means you can make the mold as per your requirement. Forging, you are very limited in this thing. You cannot make in complex designs, but the strength is more in forging. Good mechanical properties, yield strength, ductility, toughness, generally stronger and more reliable than castings. Weakness of casting is more defects because of. One second. More defects because of casting the process. You will have more cracks or voids or whatever porosity or so much defects inside the castings. Once the final casting is taken out, and machining during the machining process, you will come out a big void or a crack inside, or a porosity inside, which will affect the whole process of manufacturing. But in forging, you won't find such defects, mainly because of the manufacturing process. Size and weight, no real upper size limit for casting, but we have a very limitation in forging. Complex parts are no problem in casting, but it is we cannot make complex parts in forgings. Defects, because of defects, you'll have to spend a lot of money and time for NDT in castings. For forging, simple ultrasonic testing will do, and mostly you won't come across defects much in forging like castings. But overall cost is of casting is less, but the cost of forging is more. Material size and complexity point casting is better. Material strength point forging is better. So these are the differences between casting and forging. And now we have I've given the chart for materials used in walls. So these are all the materials we have found: carbon steel material, low alloy steel material, high alloy steel material, stainless steel material, nickel base alloy, and copper base alloy. Here, non-metallic materials have gone. This all rubber based and this ERP and other materials. This plastic, this are all for gasket and packing related items. For metallic materials, we have all this carbon steel material, low alloy steel, low high alloy steel material, and we have the grades also given for carbon steel material. Example, 8216 WCB and low carbon steel material. And for easy reference, this will be helpful. I have taken all this for easy reference. This WCA, WCB, and WCC material, A216A, rod cast, grade A, grade B, grade C material, A216. And here are chemical properties here, and yield strength and tensile strength is given, and fluid service application also given. And here it is low temperature carbon steel material, LCB, LCC, and other material. And here you have this notch toughness requirement also given here, sharp PV notch toughness. And application is low temperature non-corrosive plates. The material grade is LCB and LCC, LC2, LC3, LF2, LF2 or something like that. This you can have as a ready reference also in case you go. This is high carbon steel material, high temperature carbon steel material. These are all the grades of casting grade also is given, and forging grade is also given in this table. And stainless steel material. Stainless steel, ferritic austenitic stainless steel Dupex. Nickel base alloy material. And two nickel base, the alloy and other materials. That's all. These are all the materials what we are using for the construction of casting and construction of wall body and bonnets, and also the other trim materials. Okay, this is I think this is the end of part one, basic concepts. I think next we'll have, in the next session we'll have details about the inspection and testing part. Part two in next walls part two, inspection and testing part will discuss. So anything we need to do, any of you having any other doubt regarding this basic concepts? Hello.
Yes, sir.
Yes, sir.
Sir.
So actually, we have we have just went through the basic concepts of walls, the type of walls and operation type and basic principles of working principles of walls and materials. And next session, I think hopefully we'll cover inspection and testing of walls, which is more important. But this basic concept also is equally important. That's why I covered this in this first session. I don't want to go in a single session. I don't want to go elaborate. I don't want to cover all the basic concept as well as inspection and testing methods. So I just limited to the basic concept in this first session. And in the next session, we'll see about the inspection and testing of valves. So if anybody is having any doubt, you can call me and ask me, or anything else. If anybody wants to.
I think any doubt I will come, sir.
Okay. Sandeep?
Yes, sir. No doubt, sir.
No doubt. Okay.
Yes.
Okay. You already do this